So next, I'm going to talk about our daily experiment with some interpretation of the mechanism. What we see now is the whole mechanism of our experiment, which is somehow complicated, but I'm gonna explain it in an easy way with pictures of the experiments, and it's gonna be fun. First, we set up our experiment. We check our signal notebook, choose a pyridine or pyrimidine for the day, and calculate the amount of starting materials for the experiment. Write it on a note and get started. Then we weigh the pyridine or pyrimidine in a vial with a stir bar. Add certain amount of triflucan hydrate into it. Put it above a stir plate and wait for about 5 minutes so as to completely activate the pyridine or pyrimidine, which means to become more reactive. Besides, for pyrimidine, we use DCE as our solvent. For pyridine, however, we use DCM as our solvent. Also, cold temperature is required for pyridine, so we put dry ice and isopropyl alcohol into the dewar to drop the temperatures and immerse the vial in the solution. The reason why we don't use water in the dewar is that the freezing point of the water is so high that it will freeze easily, while isopropyl alcohol doesn't. After pyridine or pyrimidine gets activated, we add certain amount of dimethyl aspartate into the vial. Wait for about 20 minutes to make an AN-RORC reaction. Briefly, this reaction is the addition of nucleophile, ring opening, and ring closing, which is a special type of substitution reaction that helps to explain product formation and distribution in some nucleophilic substitutions, especially in heterocyclic compounds. In this case, dimethyl aspartate, which has an N15, acts as a nucleophile, opens and closes the ring here, and turns the products into this. As you can see, this is the detailed mechanism. Then what we need to do is to cut this single bond so as to separate these two things, because we only want the pyridine or pyrimidine with N15. Therefore, we add a base, which is DBU, to attack the hydrogen here. Let them react overnight and then we got this too. The next step is obvious. Separate these two compounds. So we run a column, which is column chromatography, as I mentioned before. We use TLC to find a solvent ratio that works well with the compounds and apply the solvent to the column. Then we can get some test tubes of the solution that's supposed to contain only the product we want. After that, we want to determine the test tubes that have the exact products in them. Besides, usually 60 to 70% of test tubes don't have any compound in them. So we spot every 2 to 3 test tubes on the TLC plate. Since our products are UV active, we can see them under the UV light, so we can determine which test tubes have the compound we want. Then we put our solution contains the compound into the rollabag to remove all the solvents from the compounds. After that, we use NMR to determine the purity of our products. If our product is pure, the weight of both the vial and the compound minus the weight of the vial is our yield. However, if our product isn't pure, what we do is to rinse the vial with DCM, transfer the whole solution into the pipette with cotton at the bottom, draw lines on the prep plate and run that prep plate. Later, we can see the compound we need separated under the UV light, so we circle them and scrape off the compound with a small blade. After that, what we need to do is to separate the compound from the silica. So we transfer all the powder into another pipette with cotton inside. Add some polar solvent into it and use a pipette pod to squeeze down the compound. Then put the solution we got into the rollabag again and get our yield if we're sure our product is pure.